All right, thank you so much for joining us today. In the previous video, we talked about general rule and then the rules for differentiating individual function. So I'm come to talk about different rules again here. And at the end of the video, you will see that I'm going to categorize them into whether they are going under the general rule or the rule for differentiating individual function. In the same video, we are going to take practice example and then I'll give you a trial question to solve. So stay here with me and let's learn together. Now we are talking about exponential functions. So you see that some of the functions that we are going to differentiate, some of them are exponential functions. So the question is, how can I differentiate, or what's the process of differentiating an exponential function? That's what we just need to learn. We learn three rules here and then we solve some example and then we see what we can do. So if I have y is equal to e to the power x, the question is, now if I want to find y prime or dy over dx, what is the process? Now this is the process that you need to go through. So here dy over dx, which is y prime, is, now what you need to have in mind is anytime you are differentiating an exponential function, if you know what I'm going to talk about, then you are done. You don't need to do anything again. Just think about it and then you just use the process. So what you need to do is anytime you have an exponential function, differentiate what is on the top. So I will just use different colors to do that. Differentiate what is on the top. So you see that what is on the top here is x. So I differentiate what is on the top, right? Then I multiply it by the function, the whole of the function again. That is the process of differentiating an exponential function. And knowing this, you will be able to differentiate all exponential functions in this form like this. That you see something like e to the power, anything that's going to be on the top, you'll be able to differentiate that. So what did I do? I differentiated what is on the top and then I multiply by the function itself. So this is how we differentiate an exponential function. So this is going to give us 1 times e to the power x, and this is going to give us e to the power x. So we know that when I differentiate e to the power x, I'm going to get e to the power x. But this is the process. Maintain everything and then multiply by the derivative of what is on the top. Is that right? Good. So now we know how to differentiate an exponential function. Let's talk about the natural logarithm function, len, right? Now, the len function is also having a way of differentiating, right? So let's talk about that one and then look at what we can do. So if I have this, the question is what is dy over dx? Now, the len function is, this is how the len function also go. Here is 1 divided by what is inside the bracket. Don't forget, 1 divided by what is inside the what? The parentheses. Let me say the parentheses times the derivative of what is inside the parentheses. That's x. So this is so pay attention to the way we are differentiating them. Have them in mind and then you are good to go. So this kind of something that we need to know. So now for us to differentiate the function, we are saying that 1 divided by x times the derivative of what is inside the parentheses. So when I do this, I'm going to have 1 divided by x times, when I differentiate x, I get 1, and this is going to give us 1 over x. So when I differentiate len x, I get 1 over x. But know the process, most especially this one. 1 divided by what is inside the bracket times the derivative of what is inside the parentheses. Good. So this is exponential function, and this is the natural log function. Let's talk about the log function itself. So we have the natural log function. Let's talk about the log function itself. Then we take some example. Then I'll show you the rest of the thing. Then we'll end this video. So I have y is equal to log of a, log of x base a. Now when I differentiate this, what am I going to get? This is dy over dx, which is equal to, now let me put this one in parentheses so that I can use the idea of parentheses. This log goes with like the natural log, so it's like kind of going like 1 divided by what is inside the parenthesis times the derivative of what is inside the parenthesis. So you see, like, this one is almost like this one. 1 divided by what's inside the parenthesis times the derivative of what's inside the parenthesis. But this guy here is having base a, so we need to make use of the base a. So this is kind of modifying. We want to modify the denominator here by adding the natural log of a. So it means that when I want to differentiate the log function is 1 divided by what is inside the parenthesis times the natural log of the base or times the derivative of what is inside the parenthesis. If you know this algorithm, you'll be okay to differentiate all log functions. So that is how we differentiate the log function. So no matter how the function is, you can just try it and then you are going to get the results. Simple. So this is how we differentiate a log function. So let me differentiate this. This is going to be 1 over x natural log of a times 1, and this is going to give us 1 divided by x natural log of a. So this is how we differentiate a log function. Let's take some example in practice. Right? So now, as we are moving along, I try to combine what we've learned from the previous video and then we send it along. So now looking at this function, you see that this function, we need to use the property or the rule from the previous video, which we were talking about, the product rule. So now the first thing that I need to identify here is product rule. So since it's a product rule, I need to have a, I need to have my b. So I'll pick the first function to be a, second function to be b. So a is equal to e to the power minus 2x and b is equal to the natural log of 2x. So this 2 now is what we just learned. So now what is a prime and what is b prime? So we just learned this one here, how to differentiate this. So let's see if we can go through that. So we said for us to differentiate this exponential function, we need to differentiate the exponent, the power here. So we are going to differentiate the power, which is minus 2x. Then we multiply it by the whole function. So that's what we've done. Differentiate what is on the top and then maintain the whole function. Let's try and simplify and see what we are going to get from that. So now simplifying this, when I differentiate minus 2x, I need to use the power rule. So this is going to give me minus 2, and then this is going to give me this. So you see that if I know this process, I'm done. Let's look at b prime. This is the natural log function. We said the natural log function, we do it by saying that 1 divided by what is inside the parenthesis times the derivative of what is inside the parenthesis. Good. So let's do that. What are you going to get from here? You're going to have something like 1 divided by 2x times, when I differentiate 2x, I get 2, and this is going to give us 1 over x. Good. So now that we've done the whole process, then now let's look for the f prime itself. So let's do that. Let me just shift this one here so that I can be using the space. So now we know how to go through the process. So now what is f prime? We know that the formula for finding the product rule is just kind of like a b prime plus a prime b, right? So I just need to multiply a to b prime and then a prime to b prime. It's the same thing. So let's do that. Let's multiply them. What is a? A is here and then b prime is here. So I just multiply that. I'm going to have e to the power minus this times 1 over x plus a prime is this multiplied by this. So I'm going to have minus 2e to the power minus 2x times natural log of 2x. So simplify this and then boom, we are having something like e to the power minus 2x divided by x minus 2e to the power minus 2x natural log of 2x. So this is very simple, and when it becomes very good, you can just do it straight like the way we are doing here without going through this. But going through this process by choosing your a, b, finding your a prime and b prime, it's kind of the safe way for you to avoid mistakes. But we have some people, for me, like the one I'm doing it for myself, if I'm taking exams and it's derivative, I don't do this because I know how to do it very well. So I can use my eye to do this. But if we are now starting, it's the best way to start practicing this one. And when you solve more example and you see the pattern very well and you know how to differentiate individual functions, then you go through the process. Now let's look at B, right? B. Now B, we don't need to simplify. This is the sum rule. So let's go through the process by using the sum rule to differentiate the function. So gen prime of x is equal to, when we are differentiating this, we are using the power rule. So 5 minus 1 plus, now this is the log function. So we need to use the log rule. So this is going to give us, the log rule says that 1 divided by what is inside the parenthesis, which is 2x, times the length of the base, which is 2. So length of the base, which is 2, times, now we need to differentiate what is inside the parenthesis, which is x squared. So please don't forget the rule, the process. Then plus, when you use the constant rule, when you differentiate the constant, you get 0. So you see the way I'm applying the rules. So this is going to give us 5x to the power 4 plus 1 over x squared 2 times. Now when I differentiate x squared using the power rule, I'm going to have 2x. And finally, this is going to give us 5x to the power 4 plus 2x divided by, or even I can even cancel one of the x, right? I have x squared here, I have 1x here, one of them will cancel, so it will be 2 divided by x and then 2. So this is what I'm going to get when I differentiate this. So please try and then understand what we are doing here. Now let's do this one again. This one we are going to use the quotient rule. So since as soon as I identify this a quotient rule, I pick u divided by vn, and then picking u divided by vn, now I need u is equal to e to the power x plus 1, and then vn is equal to x squared. So having this here, this will now help me to differentiate u prime and vn prime. So what is vn prime? X squared is 2x, and then we'll just learn how to differentiate an exponential function. So when you become very good, you don't need to now write them. So the idea is that if I want to differentiate this, I differentiate the top, which is, when I differentiate x plus 1, I'm going to get 1. So I differentiate the top, which is 1. Then I multiply by the whole function, which is x plus 1. So this is going to give us e to the power x plus 1. So do you get it? So basically that's how it is. So practice, and you become very good. Good. So now that we are done, what is the quotient rule? Quotient rule says that if I have this, then this is vn u prime minus vn prime u divided by vn squared. So let's just do substitution and we are done. Vn is x squared, u prime is e to the power x plus 1 minus vn prime is 2x, and then u is e to the power x plus 1 divided by vn squared. Vn is x squared all squared. Now if you want to simplify, then we can write this one as x squared e to the power x plus 1 x plus 1 minus 2x e to the power x plus 1 divided by x to the power 4. Yeah, I think we can factor x out and then just cancel one of the x. Yeah, we can do that. So when I factor, I can even factor x and e to the power x plus 1 out. I'm going to have x minus 2 divided by x to the power 4. Cancel one of the x out, and then I think our final solution is going to be something like that. Our final solution should be ex plus 1 x minus 2 divided by x to the power 3. So differentiation, it's kind of very simple. Like, it's the most simplest math. You don't need to do a lot. All you just need to do is remember the procedures and then get them right. That's all. Now let's look at Q. Now for us to solve this, we need to simplify some of the functions first before we can go through the process. So Q of x is equal to 5x to the power 4 plus x to the power 1 over 2 plus e to the power minus 5x plus the natural log of x squared plus x. So we just simplified the square root of 2 so that we can now do it. So now we know that we need to use the sum rule, right? They are all sums, so sum rule. So now we can now differentiate and we use the individual rules. So this one I'm going to use the power rule. So this is going to give me 20x to the power 3. I hope you understand it now. So 4 times this, subtract 1, giving us this. Then x to the power 1 over 2 is the same as 1 over 2x, 1 over 2 minus 1, plus, now differentiating this, now we know how to differentiate an exponential function. We said differentiate what is on the top. So when I differentiate what is on the top, I'm going to have minus 5, right? So I differentiate minus 5x, I get this. Then I multiply it by the whole function, which is minus e to the power minus x5. Then plus, now we want to now differentiate the natural log function there. So what are we going to get from here? Natural log function, we said 1 divided by what's inside the parenthesis times the derivative of what is inside the parenthesis. Remember that. So now this is going to give us 20x to the power 3 plus 1 over 2x to the power minus 1 over 2 minus 5 e to the power minus 5x, and then plus 1 over x squared plus x. When I differentiate the 1 there, I'm going to have 2x plus 1. And my final simplification here will be 20x to the power 3 plus 1 over 2 minus 5e to the power minus 5x plus 2x plus 1 divided by x squared plus x. So this is what I'm going to get at the end of the day. So you see that it's kind of very simple. When you understand it and you are doing it, it's not difficult. So please try and then be practicing. And then let's do the last example. I give you the information that you need. Then I give you a trial question to solve. So the same thing, this one we need to use the quotient rule again. So you see that when you solve more, you become very fluent with it. And then you just start using whatever you want to do. So u is equal to square root of x plus 2x. So I need to simplify this to x to the power 1 over 2 plus 2x. Then is equal to e to the power 5x. So what is u prime? U prime will be 1 over 2 x 1 over 2 minus 1 plus, when I differentiate 2x, I get 2. Simplify this and I'm going to have 1 over 2 x to the power minus 1 over 2 plus 2. Now let's look at Vn prime. Vn prime will be equal to, so exponential function, differentiate the top, multiply to the whole function, which is very simple. So I love exponential functions, very simple to differentiate. Okay, so now let's look at the quotient rule. F prime should be Vn u prime minus Vn minus u Vn prime divided by Vn squared. So let's just plug them in. What are we going to get? Vn is e to the power 5x, and then u prime is 1 over 2 x to the power minus 1 over 2 plus 2 minus u is, we can use the one with the root x plus 2x times Vn prime. Vn prime is 5e to the power 5x, all divided by Vn squared. So Vn squared is going to be this, all squared. Sometimes you can just leave your answer in this form if you are not asked to simplify. So if I want to simplify this one small, I'm going to have something like 1 over 2 x to the power 1 over 2 minus e to the power 5x plus 2 e to the power 5x. Then if I want to multiply this one square root of, let me say, x. So this one will be 5 square root of x e to the power 5x minus 10x e to the power 5x divided by, this is going to be e to the power 10x. Yeah, so this is what we are going to get for this question. Let's do this last one here. I'm sure this is the last one, then we are done. So here a prime of x, this is a length function. So 1 divided by what is inside the parenthesis times we take the derivative of what is inside the parenthesis. So this is going to give us 1 divided by 9 minus x to the power 3 times differentiating this, and we are going to have minus 3x squared. And then this is going to give us minus 3x squared divided by 9 minus x cubed. Yeah. So now we've added some things to it. So now let's look at the general rules. So still the general rules, still we have the constant multiple, sum and difference, product rule, and quotient rule. And the rules for differentiating individual functions, we've added new three to it, right? So now we added an exponential function, and we said if y is equal to e to the power x, then this implies that y prime is equal to x prime. So meaning that x prime means that I'm differentiating x. So you let me write it this form, then times e to the power x. Then the natural log function, if y is equal to the length function, and we saw that y prime should be equal to 1 divided by x times the derivative of what is inside the parenthesis. And we saw that if the function is the natural log function, which is equal to log of x base a, then y prime should be 1 divided by x length of the base times the derivative of what is inside the parenthesis. So these are the new three things that we've added to the rules for differentiating individual function, right? So now have it in mind. We can have a constant, we can use the power rule, we can have a function which is an exponential function, natural log function, and then log functions too. So you see that in the next video, now I'll combine everything on this, and then we'll be building it up. So we'll finish all the rules, and then now we pick some questions that is like all together, all round, and then we just solve them together. So now I will show you your trial question. You do it and you put it in the comment section. As I said, I appreciate those that they solve and then they leave their answers in the comment section. At least it helps me to do some reply on YouTube, and it's kind of very nice. So please solve it and leave your final results in the comment section. In the next video, we are going to also learn different rules, that we can also use to differentiate different functions, and then we add them together and then we build up. So see you in the next